Hi, I'm Gareth Spence and welcome to Tech Talk. As this year's OFC comes into view, IP over WDM is proving to be a hot topic, especially when it comes to choosing the right OLS to maximize network performance. To break it down, I'm joined by Adtran's Stephan Rettenberger. Stephan, let's take this from the top. What is IP over WDM?
Well, IP obviously stands for Internet Protocol, so we refer with that abbreviation to the routing technology that is omnipresent in today's networks. The WDM, that's wavelength division multiplexing, that's the technology that multiplies the fiber capacity. Historically, the IP layer was treated quite separately from the optical layer, both managed independently with very clear demarcation through an OEO device, an optical to electrical to optical conversion. IP over WDM refers to an architecture where we try to feed as directly as possible out of the IP device, the client device, into the optical layer without any unnecessary OEO conversion. We expect a leaner architecture, smaller footprint, lower power consumption, and therefore a better economy of scale.
Why is choosing the right OLS so important for IP over WDM systems?
The optical layer is quite analog in nature, so there's typically a lot of engineering involved to make sure you can deal with the fiber impairments, things that happen as the light is traveling through the fiber. So there's a lot of sophistication going into that optical layer. And to oversimplify things, the IP domain typically does not know much about that optical layer. So having an OLS that is rather robust and independent of the IP layer while you're still feeding it directly is extremely important. And depending on the topology, the reach, the total amount of capacity that you're trying to transport, you may have different choices and considerations in the technology that you put into the OLS. So it's a sophisticated piece of equipment, ultimately designed to make it very easy.
What challenges might operators face when integrating an OLS into an IP over WDM network?
So I think the biggest challenge is that these domains were treated completely separately. So there may be a very simple and obvious challenge, and that is two separate departments that operated independently all of a sudden need to merge their technologies, and they may not be willing to do so. The technical challenge really is who is in charge of the end-to-end performance of that link. Is it the optical guys that need to make sure the signal that enters is making it to the other end and through the network as we speak? Or is it the IP department that needs to make sure the layer functions? So I guess having clear boundary conditions, who is doing what and who is controlling what in that architecture, is the biggest obstacle to overcome, because you somewhat lose that very clear demarcation that you had when you treated them completely separately like you would do in the past.
And what are the benefits of an open, disaggregated, multi-vendor approach in IP over WDM solutions?
So today's day and age is all about choice, picking the best in breed technology for everything you're trying to do in the network. So having an OLS that is tailored to the application that you're trying to address, having a choice of transceivers that can work with that OLS and that can plug into your IP device and not being rejected. So there's a couple of things that really need to come together in this open and disaggregated solution. Having said that, by picking the best in breed ingredients and making it work end to end gives you the best price performance you can find in the market and will give you some future-proof scalability. You become independent of innovation cycles, so something may be on a faster trajectory, so you can optimize individual pieces without being stuck in a book-ended, end-to-end single vendor solution.
Stephan, thanks for joining me today.